Today, I'm analyzing applied materials using Fortune's most admired framework. I selected the dimension of innovativeness. Although applied materials is financially strong and globally respected, innovation is the most critical factor in the semiconductor equipment industry. So, I will explain why innovation presents a strategic risk, how structure and culture influence this issue, and how Cotter's 8 step model can help improve long term performance. So, organization overview. Applied Materials was founded in 1967 and is a leading supplier of semiconductor manufacturing equipment. Its customers include major chip makers like Intel, TSMC, and Samsung. The company operates in a highly competitive, technology driven environment where success depends on constant advancement because semiconductor manufacturing is complex and rapidly evolving. Companies must continuously invest in research and development and remain competitive by doing so. The dimension of underperformance. So we're focusing on innovation. The dimension I selected is innovation or innovativeness. In this industry, innovation determines market leadership. Applied Materials invest heavily in research and development, but competitors like ASML, as you can see, the semiconductor value chain, just an overview of it in the image to the right. Competitors like ASML dominate certain breakthrough technologies, especially extreme ultralight lithography, EUV, as it's called. When a competitor controls a key technology, it shifts power within the industry. Even if Applied Materials performs well financially, falling behind in a major innovation could weaken its long-term position. The major issue is the risk of slower breakthrough innovation in a fast-moving industry. Large, mature organizations sometimes prioritize efficiency and predictable returns. However, semiconductor manufacturing requires bold experimentation. If innovation becomes too incremental or overly controlled, the company may struggle to lead future technological shifts. Ramifications. If innovativeness declines, several consequences follow. The company could lose market share, could reduce differentiation, and weaken strategic partnerships. Research on competitive advantage shows that sustained innovation is directly tied to long-term performance. So in a technology race, companies that hesitate fall behind quickly. The likely consequence of failure to improve is reduced influence in shaping the future of semiconductor manufacturing. Organizational structure. Applied Materials uses a divisional structure with a strong engineering and leadership and formal processes. While this creates efficiency and quality control, innovative organizations benefit more from flexible and organic structures. If decision making is too centralized or layered, experimentation slows, and structure directly affects the company's ability to innovate. Organizational culture. The company promotes engineering excellence and operational discipline. These are strengths, but they can also create risk aversion. Culture is shown through daily behavior, not just values posted publicly. So if employees feel that failure is not punished, they will avoid bold ideas. Innovation requires psychological safety and support for experimentation. Conscious culture. Applied Materials promotes sustainability and technological progress, which aligns with principles of conscious management. However, conscious leadership also requires empowering employees and creating long-term stakeholder value. Strengthening innovation internally would better align the company's culture with its stated mission and long-term purpose. Kotter's change model. To improve innovativeness, I would apply Kotter's 8-step change model, and Kotter explains that a successful change requires urgency, leadership, alignment, a clear vision, employee engagement, removal of barriers, short-term wins, sustained momentum, and embedding change into a culture. This structured model helps ensure change is lasting rather than temporary. Applying Kotter. First, leadership must create urgency by presenting a competitive innovation data. Second, form a coalition of R&D leaders and respected engineers. Third, create a clear innovation acceleration vision. Fourth, communicate it across global teams. Fifth, remove barriers like excessive approval layers. Sixth, pilot rapid innovation teams to produce short-term wins. Seventh, expand successful initiatives. And finally, anchor innovation into performance evaluations and reward systems so it becomes a part of the culture. Challenges and alignment. Challenges may include resistance from middle management and concerns about financial risk. To succeed, multiple subsystems must align. R&D funding must support experimentation. Incentives must reward long-term thinking. Communications must encourage collaboration across divisions. According to the congruence model, effectiveness depends on alignment between structure, strategy, and culture. Lessons learned. From this analysis, I learned that innovation requires structural flexibility and cultural support. And as a manager, I would prioritize clear communication, cross-functional collaboration, and tolerance for intelligent risk-taking. I would avoid over-centralization and short-term thinking. Long-term competitiveness depends on creating an environment where innovation is consistently supported. And in conclusion, Applied Materials is a strong company, but innovation is critical in its industry. Structural rigidity and risk-averse culture can limit breakthrough development. But by applying Kotter's change model and aligning internal systems, the company can strengthen its long-term competitive position and maintain its leadership in semiconductor technology. Thank you.